Hey, what's up guys? Alex here from RoboDK, and today I'm going to show you a new feature in RoboDK, which is the collision-free motion planner. Now, this is a PRM motion planner. You don't necessarily need to know what that means, but if you're interested, PRM stands for Probabilistic RoadMap algorithm. If you want to know more about how this algorithm works, you can check out the blog, and it has some articles about that. But all you really need to know to use this feature is that it is a feature that allows you to automatically generate collision-free paths between areas in the workspace. And in front of us you can see the output of this feature. We have a welding task on one side of the table, another welding task on the other side of the table, and an obstacle in the middle, and a path that has been generated automatically using the collision-free motion planner. So let's jump to a setup with no obstacles. And just as a point of reference, I just want to show you how you would normally program a movement in free space in RoboDK. So normally, if you wanted to move between 2 points in the workspace, let's say safe 1 here, which is an offset away from this welding task, and safe 2, which is an offset away from this welding task, I would always recommend you use an offset in a kind of safe location in the workspace before you make these kind of big movements, just because we're using joint movements, which are not the most precise movements and have the possibility that they might collide with something. So if we wanted to program a movement between these points, you would first click on the starting point, click joint movement. This will create a program, and then move to the end point and hit joint movement again up here, and that will generate a movement. So we'll jump back here. That'll generate a movement between those 2 points. Very simple. But what happens if we have an obstacle in the workspace? So let's jump through to another setup. It's exactly the same setup, but this time we have an obstacle in the middle. Now, if I was going to move between these 2 points again, same way, joint move. If I wanted to move between those, if I run this program now, we get a collision. Now, if you find that you're running a program and it's not colliding and you think it should, check that you've got the check collisions box activated. You should have a tick instead of a red cross. If you were to run this without that, you'll see that the robot goes through the box, through the object. We don't need that. We want it to check the collisions, and in that case, the robot will collide with the box, which is the sort of thing that the motion planner will allow us to avoid. So let's just delete this program and open up the new motion planner window. So you can access this by clicking the little arrow next to the check collisions box, and you'll see there's an option that says create collision-free map. And this brings up the collision-free motion planner panel. Now here I've entered the number of samples as 10, the edges per sample as 5, and the robot step as 4. When you open this up the first time, you'll probably get the defaults, which are 100, 25, and 4. But I would recommend using a smaller number just the first few times you run the motion planner, particularly when you're designing your setup, because every time you add a new object into the workspace, you're going to have to run this again. So if you choose small numbers, it won't take a very long time to generate. So let's just hit Update Map. And what it's doing now, it's creating 10 randomly placed samples within the robot's workspace. So randomly placed locations. And it's trying to connect those 10 locations together using 5 edges. And an edge represents a path which won't have any collisions in it. So as you can see, this generates quite quickly. And now that's finished, we can display the map that we've just generated by clicking Display Map. So there you go. These lines represent those edges, and the points that they meet are the samples. Now, this particular map is reasonably well distributed, but sometimes you'll find that there are many points, or some points, that are way outside of the workspace that you're working with. And to avoid this, you can set the joint limits on the robot, and actually this is a good thing to do. So you can get to the robot panel by double-clicking on the name of the robot here, or you can also get that by right-clicking and going to Options. And you'll see that the joint limits for the first joint of the robot are between -180 and +180. Now, we're not going to use this part of the robot's workspace, so there's no need for us to be able to access that. So we can double-click on any of the lower joint limits here, and this will open up the Set Lower Joint Limits panel. And for this example, we're going to set this first one to -60, and the third joint to -60 again. and we're going to click OK. And then double click on any of these ones, these upper joint limits, to open up the Set Upper Joint Limits panel. And we're just going to change this first joint to plus 60 and then click OK. So now when we regenerate the map, click Update Map here, we'll see that the points that it generates are more localized around the area of the workspace that we're going to be working in. So there we go. We have points that are nicely located around the workspace. Let's close this panel. Now, let's look at how we would generate a program between those two same points that we generated the program before. It's very easy with the motion planner. First, let's say we're going to move from safe 1 to safe 2. So you just need to select the targets in the station tree. This is the station tree. And you select the targets in the order that you want them to move. So to move from safe 1 to safe 2, we'd select them in that order. So we click safe 1 here. We hold down the control key and click safe 2 there. Then right click on either of those targets and go to link selected targets. This will generate a collision-free path between the 2 points using the map that we generated. As you can see, it's routing it through that point there and moving down there. Now, because it's a small map with 10 samples and 5 edges per sample, it's not the most efficient movement, but it's a quick movement and we generated the map quite quickly. Now, if we want to move in the opposite direction, we just select the targets in the opposite order. So we'd click on safe 2, for example, hold down control and then safe 1. And then we can also do the same. We don't need to right click. We could also click on link selected targets and programs here in the panel. And that will again create a collision-free motion between the 2 points. So we now have that movement and we have that movement. So what if we want to add a new target into the workspace? Do we have to generate the entire map again? No, we don't. We can do that using the Add Selected Targets button here. So let's imagine that we want to move to a point just on the top of the box here. We can do this by holding down the Alt key, and we can click and drag the robot to the point that we want to make it the new target. Let's say it's there, and we can create a new target at the top here. Add new target. So now we now have target 3. If we want to add that into the map, all we have to do is click Add Selected Targets. Now, you'll notice down the bottom there is an option, New Sample Edges. So this is the number of edges, as with when we generated the map, the number of edges that the PRM algorithm will connect the new target to the existing targets, to the existing samples within the map. So we're going to set it to 5, which is the same as it is up the top. And we're going to click Add Selected Target. And it will run through the PRM algorithm, just adding in that 1 point. And as you can see, now that target is also added into the map. So if I want to make a movement, say, between target 3 and safe 2, the offset there, I just click target 3, hold down the control key, safe 2, and then link selected targets and programs. And it will create a collision-free motion between those 2 targets using the closest, the smallest movement that it can, which in this case is through that point as well. Now, let's delete these programs. What happens when we want to have a slightly more efficient movement? So those movements that we had routed all the way through this point, which is quite far away really. The way to make a more fine-grained map is to increase the number of samples and the number of edges per sample. So let's increase it to the default, which is 100, 25, and again 4 for the robot step. And I'm going to speed this up, but this generation at this type of numbers usually takes about 15 minutes on a reasonably good computer. So let's hit Update Map and see what that looks like. So now we can see that the motion planner has generated a road map with 100 points in it. And you can see down here in the panel, it says 100 samples, and there are 1,594 edges connecting those samples. And if I turn off the map, we can now see what it looks like when we link 2 of those targets together. So let's use those safe 1 and safe 2, the offsets that we've been using so far. So again, we need to select the first point, and then we hit the control key, select the second target, and then we can right click on it or click on that button and link selected targets. and that will generate a collision-free path. So this one goes off there. This is going to be a smaller path than the one we had before. It still moves to this point on the map. Obviously, if I turn on the map, we can't see that now because it's completely obscured. But this is a much more efficient movement than the one that we were using previously, which went all the way over here. So when you've set up your workstation and you know where your objects are going to go, you want to do that. You want to generate that map with more points, and you'll get this type of finer grained map, which you can then use and add new targets to, as we did before. And the more points that you put in your map, the more samples, the finer grained that map will be. Now there's just one other feature that I want to show you, and that's a similar feature to connecting the two targets together, but it's connecting two programs together. So I'm just going to jump to a different section here. So here we have the same sort of setup. I've generated a map with 100 samples and 25 edges per sample. They're slightly differently distributed because every time you run that update map, it's going to place the points on the map in a slightly different place. But in general, we've got a similarly sized map. And I've created two different programs. So we've got this welding program, and this is weld cylinder. So it's going to move into that cylinder. It's going to turn on the welding tool. It's going to move around in a square in this case, and then go away back to the safe 1 point to that offset. And then we've got another program on the other side. So we're going to move to the safe point over there, and the welding of this casing here. So that will weld around the edge. And we're going to see how we can link these two programs together using the collision-free motion planner. So first, as before, you click the program that you want to come first, in this case, weld cylinder. So we're going to move over to safe 1 and weld cylinder, and then hold down the control key, hold weld casing, and then we right click and go to link selected programs. Or again, you could click that button in the panel on the left if that's open. Now what this is going to do is it's going to create a new main program. It's going to create a program which is the motion. So we jump back over here. If I run that motion on its own, it's just a collision-free path as before. But when I run this main program, let's jump back to the start again, it will first call that welding program. It will then move in a collision-free path, and then it will call the second program. So I run the main program, and that will run it like that. And this is really useful if you've got multiple parts of the workspace where you have different tasks and you've created little programs, maybe printing programs, maybe machining programs, maybe assembly programs, doesn't matter what they are, but you've got them in different parts of the workspace, and you just generate your map, your collision-free map, and you can use the planner to automatically route the robot between those points without having to worry about collisions within the workspace. So that's about all you need to know to use the collision-free planner. There is also a documentation page, and there are a few blog posts. But for the moment, I'd say just try it out for yourself. And if you want something else to watch here, I would recommend you watch one of our other videos.